Alright, hello and welcome to the next video. In this video we are going to demonstrate how to use the least common multiple in real life situations. So using the least common multiple in real life. Woo! Real life. So you guys might remember in class when I was talking about our two Ferris wheels. Remember how we had two Ferris wheels at the lovely fair? And I'll try to draw these a little bit better since I'm on the internet now. I didn't do a very good job in class. Now I have two Ferris wheels, and I remember that one went around in 30 seconds and one went around in 50 seconds. I know, it's a very quick Ferris wheel, and that one's kind of probably still sort of quick, but that one's really quick, right? And I had a friend at the bottom of this Ferris wheel and a friend at the bottom of that Ferris wheel, and I was asking, okay, let's say that these friends are at the bottom of my Ferris wheel and I'm right here. I'm standing right here and I'm trying to take a selfie with myself and my two friends in the same picture at the same time. Because I can do that because the Ferris wheels are right next to each other, and it just so happens I'm close enough and it all works out. Okay, but then once they go, and remember, I'm not much of a Ferris wheel guy, I'm more of a giant drop kind of person, so I'm about to go over here. Before I do that, I'm about to go and get some food and things at the fair while they go up. Okay, so these guys are going to go up in the wheel, and the 30-second one is going to come all the way around before the 50-second wheel has finished. But then when the 50-second wheel finishes, the 30-second wheel is already going back up. So it's this big old mess, and I don't know when they're finally going to come down at the same time, but when they do, I want to be back in time from getting all my food and riding the giant drop and all kinds of stuff. I want to be back in time so I can take another selfie with them. So basically what we're looking at here is we're looking at different times that each person is going to hit the bottom. So notice my first friend in the smaller Ferris wheel, well, the first time that they're going to come all the way around is in 30 seconds. Okay, the first time they come around, it's going to be 30 seconds later. Well, it's because it takes 30 seconds to go all the way around. So the second time they come around, well, that's another 30 seconds, so overall, that's at the 60-second mark. Okay, the third time around, well, it's 30 more seconds, that would be 90 overall. The fourth time, that would be 120 seconds. The fifth time, that'd be 150 seconds. The sixth time would be 180 seconds. And I could keep going, but I'm going to choose to stop there, because remember, multiples go on forever. So I could keep going, but I'm feeling pretty good with that. And I don't know about you, but I don't want to sit here for the rest of the night or the rest of my life even, because it's possible, listing out factors of 30. Or, listing out multiples of 30. I don't want to sit here too much longer and do that. Okay, I have better things to do. And I'm sure you do too. So, these are all the time intervals that my second friend here is going to be at the bottom of the Ferris wheel. So now let's do the same thing for my other friend here in the larger Ferris wheel. The first time he comes around, well, that's going to be after 50 seconds. Naturally, because it takes 50 seconds to go all the way around. So the second time he reaches the bottom, well, that's 50 more seconds later, so in total, that's going to be 100 seconds. After a third time, that'll be 150. And after a fourth time, that'll be 200. But again, I'm feeling pretty good. I don't think I need to list any more than that. Okay? So, what I've just found are all the possibilities where my friends will be at the bottom of each individual Ferris wheel. Okay? But remember, I'm interested in finding when they're both going to be at the bottom at the same time. So, that must mean I'm going to have to find a common number between the two. So I'm going to play I Spy, and I'm noticing that the number 150 shows up on both sides. Now I could have kept listing these off, right? I could have said, well, after 180 comes 210, then 240, then 270, then 300. I could have kept going, and I know that this could have kept listing off to 250, and then to 300. And look, then 300 would have been a common one too. Okay? And then you have to ask yourself, well, what number is better? 300 seconds, well, that would give me more time to ride the giant drop, and it'd give me more time to eat some food and all kinds of stuff like that. But what if the ride is over before the 300-second mark comes around. Then I'll miss out on my opportunity completely to get my selfie with my friends, right? So I think 150 in this case would be the safer option. It's the smallest of all the common numbers here. Okay, so let's review what we just did. All right, first we listed out all of these numbers, and those, if you remember, were the multiples of 50 and 30. So we listed out our multiples. And notice we didn't list out all of them because that would take eternity. We listed out some of our multiples, right? So then we looked for our common multiples. We're not just interested when one person is on the bottom of the Ferris wheel. We're interested in when they're both at the bottom of the Ferris wheel. So therefore, the multiple that we're looking for has to show up on both sides because it has to do with both friends. So I know that they'll both be at the bottom of 150 seconds and they'll both be at the bottom again in 300 seconds. So those are our common multiples, weren't they? And then finally, we're going to find the least of the common multiples. Least of the common multiples. So that's where 150 came in. Okay? So let's look at another example here. Okay? In this example, we're going to look at an alarm clock. Okay, so let's say Jeff wakes up at 7 o'clock in the morning. At 7 o'clock in the morning, a.m. Okay? Joe wakes up at 7 o'clock as well. Okay? Now, Jeff and Joe both have to wake up at 7 in the morning, but I'll tell you that they don't really like waking up at 7 in the morning. In fact, they have quite a bit of trouble doing it. So when they wake up, they hit the snooze button. And I'll tell you, I'm guilty of pressing the snooze button in the morning as well. Alright? But these guys are really bad. Alright? So let's say that when Jeff wakes up, his snooze button goes for 12 minutes. Okay? So his snooze lasts 12 minutes. And Joe's, well, oops, I'm about to write Joe again. We already know this is Joe. His snooze goes for 8 minutes. You know what? I have a feeling these numbers are very similar to a quiz that we just took, which some of us might still be correcting. So, I think I'm going to change this to... we'll say 10 minutes. So, Jeff's snooze button lasts for 12, and Joe's snooze button lasts for 10 minutes. So that means that Jeff is going to wake up at 7 in the morning, and Joe's going to wake up at 7 as well, but Jeff is going to press the snooze button, and the next time it's going to come on is 12 minutes later, and Joe's is going to come on 10 minutes later. Okay, it's going to give him 10 more minutes of sleep, just in case you're not quite familiar with what a snooze button does. Maybe you're not quite that lazy in the morning as I am. Now, I'm interested in asking, once these alarms go off at 7 in the morning, assuming that these people smack the snooze button every time that they can, how long is it going to be before their alarms come off at the same time again? Okay, so to do that, well, let's follow our step-by-step procedure. First, we're going to have to list off our multiples. List off multiples. Okay, this is the same step procedure that we're taking before, except now we're being a little more explicit about the steps early on. So, the first time Jeff hits the snooze button is going to be after 12 minutes. Well, because that's because it goes off every 12 minutes, so naturally, 12 minutes later, he's going to be hitting that snooze. Okay, the next time he does it, it's going to be after another 12 minutes, so overall, that's going to be 24 minutes. Okay, how about the third time? That'd be 12 times 3, or 36 minutes. Fourth time would be 48 minutes. And after the fifth time, we're at 60 minutes. Now, I could keep going, but I have a feeling, especially after looking that Joe's is going to go off every 10 minutes, that we might have a common multiple here. Which, remember, that's going to be step 2. Okay, I'm just kind of thinking ahead now that we've seen this a couple times. But, alas, we're still on step 1, listing off the multiples. But now we're talking Joe. So Joe wakes up at 7 o'clock, and then the first time that that snooze button goes off is going to be 10 minutes later. Because, well, that's how long each cycle lasts. So therefore the second time is going to be in 20 minutes. Right? Third time is going to be in 30. Fourth will be in 40. Fifth will be 50. And the sixth time will be 60 minutes. Look, I was right. Okay? So for our second step, which is find the common multiples, we've already found it. That would be 60. And look, I could have kept listing these off, and I could have kept listing these off, and because they keep going forever and ever and ever, I mean, hopefully Jeff and Joe aren't smacking the snooze button all day long, because then they'll just waste their whole day. But they could, theoretically, just hit the snooze button for the rest of their lives if they really wanted to. I don't know who in their right mind would, but some people, you never know, maybe they're just feeling really tired one day, and they're just going to keep going. But hopefully they're going to stop after a while. Okay, but they don't have to. But I chose to stop after 60 minutes because I knew that's probably when things would match up. So that's where we found our common multiples. And then our third step is to find the least of the common multiples. And look, we only have one to choose from. So obviously this is the smallest one. Now we could have made it harder on ourselves and made more, but no matter how far we go, we're never going to find a multiple that's smaller than 60. We're never going to find, a common multiple between the two that's smaller than 60. They're only going to get bigger from here on out. So automatically 60 is already our least common multiple. So what this is saying is that after 60 minutes, Jeff and Joe will wake up at the same time and they'll hit that snooze. And for Jeff, that's going to be on that 1, 2, 3, 4, 5th slap of the snooze button. And for Joe, that's going to be the 1st, 2nd, 3rd, 4th, 5th, 6th slap of the snooze button. Okay? Similarly, when we were talking Ferris wheels, for us to come out even at 150 seconds, that required the big Ferris wheel to go around 1, 2, 3 times, and it required the smaller Ferris wheel to go around 1, 2, 3, 4, 5 times. So this was a quick video on how to apply the idea of the least common multiple into real life scenarios, and it usually involves cycles of numbers that really just, if you're adding time up or you're adding something up, they're just going to keep going forever and ever, getting bigger and bigger, potentially. In real life, generally we don't do things forever, but mathematically they could go on forever. So I hope this helped.